Namaskar, dear students, welcome. Today, I shall solve some problems on differential equations from the book Simply L. Rose, your textbook. These questions will be solved today from the book Simply L. Rose from exercise section 2.1. In the last class, we solved 4 problems 1, 2, 3, 4. Today, I shall solve these problems. Let us try to solve this question number 5. Let us try to solve this question number 5. This. Suppose this differential equation is number 1. Number 1. Compare this differential equation with m dx plus m dy. M dx plus m dy. And of course, it is a function of y, x and y, dy equal to 0. Comparing one with this, we get, you may write comparing one with this. One with this, we get m equal to 6xy plus twice y square minus 5, and this is equal to 3x square plus 4xy minus 6. Del m by del y. What is del m by del y? Differentiate this with respect to y, treating x as constant. You will get 6x. With respect to y, you will get 4y. And here del n by del x. With respect to x, treating y as constant. 6x, it will be 6x plus, it will be 4y. 6x plus 4y, del m by del y equal to 6x plus 4y, del n by del x is equal to 6x plus 4y. Therefore, del m by del y equal to del n by del x equal to del n by del x. Therefore, 1 is exact. 1 is exact. Therefore, 1 is exact. Since 1 is exact, therefore, the equation m dx plus m dy equal to 0 is said to be exact if m dx, if there exists a function u of x and y such that m dx plus m dy is equal to du, means it becomes a perfect differential. Du, this means there exists a function u of xy such that xy such that m dx plus m dy equal to du. M is a function of x and y, n is a function of x and y, u is also a function of x and y. This, which is equal to del u by del x, u is a function of x and y, dx plus del u by del y dy. Del u by del y dy. This means del u by del x equal to m is a function of x. What is m? It is 6xy plus twice y square minus 5 and twice y square minus 5. Suppose this is number 2. And del u by del y equal to n. This equal to n. And this is equal to, you will get 5x square plus 4xy minus 6. Suppose this is number 3. This is 2 and this is 3. 2 and 3. From 2, now from 2, del u by del x equal to this. Therefore, u xy will be equal to integral 6xy plus twice y square minus dx, treating the other variables as constant, plus it will be phi y. If you differentiate this with respect to y, with respect to x, then it will be 0, and you will get this one, which is equal to, with respect to x, y is constant. What will be this? Thrice x square y. X square by 2, thrice x square y. Plus twice x y square minus 5x plus pi y It is u xy equal to this. Suppose this is number 4. From 4, del u by del y from 4 with respect to del u by del y, it will be thrice x square plus 4xy plus d phi by dy. You will get this one. This is number 5. Now compare 3 and 5. From 3 and 5, del u by del y. From 3 and 5. From 3 and 5. Implies, from 3 and 5, you will get thrice x square plus 4xy plus d phi y by dy. This is equal to thrice x square plus 4xy minus 6. Thrice x square plus 4xy minus 6. xy minus 6. This means from this you will get, this means d phi y by dy, this is equal to minus 6. This means phi y equal to, integrate this, minus 6y plus a constant of integration. Therefore, from 4 we get, you will get, 4 implies u xy equal to thrice x square y plus twice x y square minus 5x. For phi y you will get minus 6y plus c. Now the solution of one is u xy equal to constant. How? Since the differential equation is exact, m dx plus m dy equal to du. given that m dx plus m dy equal to 0. Therefore, you will get d of u equal to 0. d u equal to 0 means the solution is u equal to constant. u xy equal to constant. This is equal to C1c. C1c. Therefore, from this you will get thrice x square y plus twice x y square minus 5x minus 6y plus c0 equal to c1, or you will get thrice x square y plus twice x y square minus 5x minus 6y equal to c1 minus c0, c1 minus c0, c1 minus c0. This means thrice x square y twice x y square minus 5x minus 6y equal to c, where c equal to c1 minus c0. This is equal to constant. c1 minus c0, this is equal to constant. This is the solution of the given differential equation. This is the solution of the given differential equation. X square y. Now we have solved this equation by this method. Let us come to solve this equation by method 2. This is the equation. Since this differential equation is exact, solution of one is integral m dx treating y as constant, plus integral m dy taking only those terms in n which do not contain x, this is equal to constant. Therefore, the solution is this is 6xy plus twice y square minus 5 dx. It is delta x. It means treating y as constant, plus taking only those terms which do not contain x. This contains x, minus 6y minus 6 dy equal to constant. This is equal to constant. This means integrate this with respect to x, treating y as constant. What will be this? 6y x square by 2 means thrice x square y plus y square is constant, twice x y square minus 5x minus 6y equal to constant. This is the solution. This is the solution of the given differential equation. This is method 2. In this way also you can solve this differential equation. This is method 2. Let us come to solve this equation by method 3. Let me remove this one. Thus we shall solve this equation by method 3, means grouping method of grouping. One is exact, one implies. Method of grouping implies. Here 6xy dx group 6xy dx. This is method 3. Method of grouping. 6xy dx plus thrice x square dy, group this, plus twice y square dx plus 4xy dy, group this, minus 5 dx minus 6 dy equal to 0. This means common 3 is common. Twice xy dx plus x square dy, this, plus here also 2 common, y square dx plus twice xy dy minus d of 5x minus d of 6y equal to 0. This is equal to 0. Now, this is equal to 0. This means 3 of here y twice x dx, you may write like this, plus x square dy plus 2 times of y square dx plus x twice y dy, you may write like this, minus d of 5x minus d of 6y. This is equal to 0. This is equal to 0. Suppose this one. This one. This means 3 times of y dx square plus x square dy plus 2 times of y square dx plus x dy square minus d of 5x plus 6y, you may write like this, equal to 0. This is equal to 0. This means 3, you see, first function differentiation of the second function plus second function differentiation of the first function, d of x square y plus 2 times of d of here xy square minus d of 5x plus 6y. This is equal to 0. This is equal to 0. Or d of 3x square y plus twice x y square minus 5x minus 6y equal to 0. This means integrating, just integrating, you will get thrice x square y plus twice x y square minus 5x minus 6y equal to constant. This is the solution of the given differential equation. Integrating, we get this. Integrating, you will get this one. This is the solution of the differential equations. Therefore, we have solved this differential equation in 3 methods. Let us come to solve the question number 6. Let us come to solve the question number 6. This is the question number 6. This is 1. Suppose this is 1. Comparing 1 with, comparing 1 with m, it is r theta dr plus m r theta d theta equal to 0 we get. Compare this equation, this we get. This equation with this we get. M r theta equal to theta square plus 1 cos r, and r theta equal to twice theta sin r, del m by del, what will be this? If the differential equation is m dx plus m dy, then we find del m by del y. Here we will find del m by del theta. This is equal to del m by del theta. With respect to theta, treating r as constant, it will be twice theta cos r. Twice theta cos r. Del m by del r. Del r. Treat theta as constant, twice theta cos r. It will be twice theta cos r. Twice theta cos r. Cos r. Therefore, del m by del y, del m by del theta equal to del n by del r. Therefore, one is exact. One is exact. Therefore, one is exact. Since one is exact, therefore, there exists a function u of r and theta such that m dr plus n d theta will be equal to u of r theta. This means there exists a function u of r theta such that m dr plus n d theta equal to d of u. Of course, it is r theta. D of u, r theta. U, r theta. Therefore, d of u, r theta. What is this? Del u by del r dr plus del u by del theta d theta. Therefore, del u by del r, of course, u is a function of r and theta, equal to m r theta, which is equal to, what is m? Theta square plus 1 cos r. Theta square plus 1 cos r. Suppose this is number 2. Number 2. Del u by del theta will be equal to n. What is n? Twice theta sin r. Twice theta, it will be twice theta sin r. It will be twice theta sin r. Suppose this is number 3. This is 2 and this is 3. Now, you see here. Now, from 2 implies, from 2 you will get u r theta equal to integral theta square plus 1 cos r del r plus d phi. Plus phi, it is a function of theta only. It is a function of theta only. This means, which is equal to, this means u of r theta equal to, with respect to r, treating theta as constant, it will be theta square plus 1 integration cos r is sin r plus phi of theta only. Suppose this is number 4. This is number 4. From 4 you will get del u by del theta with respect to theta partially treating R as constant. Del u by del theta. It will be twice theta sin r plus d phi by d theta. Phi is a function of theta only. Phi is a function of theta only. Of course, it is u is a function of r and theta. Right? Suppose this is number 5. This is number 5. Now, from 3 and 5, del u by del theta equal to this. From 3 and 5, del u by del theta, it is twice theta sin r plus d phi theta by d theta. This is equal to twice theta sin r. This means d phi by d theta equal to 0. This means phi equal to constant. Phi theta, this is equal to constant. C naught equal to constant. Here C naught equal to constant. C naught, this is equal to constant. C naught equal to constant. C naught equal to constant. Now substitute this value of phi theta in 4. If you substitute this value of phi theta in 4, we get therefore 4 implies u r theta equal to theta square plus 1 sin r plus c naught. Now the differential equation m r theta dr plus n r theta d theta equal to 0 is exact, and since it is exact, then m dr plus n d theta equal to u. This is equal to du. The given differential equation is m dr plus n d theta equal to 0. Therefore, du equal to 0. The solution will be u equal to constant. The solution of one is u is equal to constant. Equal to C1C. Therefore, u r theta means theta square plus 1 sin r equal to sin r, theta square plus 1 sin r plus c naught equal to C1. This means theta square plus 1 sin r equal to C1 minus C0. This means theta square plus 1 sin r equal to C, where C equal to C1 minus C0 equal to constant. Therefore, the solution of the differential equation is this. Theta square plus 1 sin r equal to C. Theta square plus sin r equal to C. This is the solution of the given differential equations. We have solved this differential equation in one method. Let us try to solve this differential equation by method 2 and by method 3. This is this differential equation. This is an exact differential equation. Therefore, method 2. The solution of one is integral m dr, treating theta as constant. Integral m means this cos r. I am writing here delta, means treating theta as constant, plus integral n d theta, taking only those terms which do not contain r, No term is there, Right. Zero d theta equal to zero, equal to constant. This is equal to constant. This means with respect to r, taking theta as constant, theta square plus 1 sin r equal to c. This is the solution of the differential equation. It is very simple. This is method 2. Method 3. This is grouping method. Method of grouping. One is exact. It has already been proved. One is exact. Method of grouping. Therefore, 1 implies theta square plus 1 cos r dr plus twice theta sin r d theta. This is equal to 0. This means theta square cos r dr plus twice theta sin r d theta, group this, plus cos r dr equal to 0. This is equal to 0. Cos r dr, this is equal to 0. This means you may write theta square d of sin r plus sin r. For twice theta d theta, you may write d of theta square plus d of sin r equal to 0. This means d of theta square sin r plus d of sin r. This is equal to 0. D of theta square sin r plus sin r equal to 0. This means d of theta square plus 1 sin r equal to 0. Integrating we get, now integrating after this, integrating we get theta square plus 1 sin r equal to constant. Therefore, we have solved this equation by method 3 also. Let us come to solve the equation number 6. Equation number 7. We have solved equation number 5 and question number 6. Here it is 7. Suppose this is number 1. Here, comparing this with m dx plus m dy equal to 0. Here this is equal to y sec square x plus sec x tan x and this is equal to tan x plus twice y. Del m by del y. With respect to y, treating x as constant, sec square x, it will be sec square x. With respect to y, it will be 0. And del m by del x will be equal to sec square x it will be 0. Sec square x, this is 0. Sec square x, this is 0. Therefore, del m by del y. Del m by del y equal to del m by del x. Therefore, 1 is exact. Del m by del x. Therefore, 1 is exact. Since 1 is exact, this means there exists a function u of x and y such that m dx plus m dy equal to du. This is equal to du. This means m dx plus m dy equal to du. This means m means y sec square x plus sec x tan x dx plus tan x plus twice y dy equal to du means del u by del x dx plus del u by del y by del y dy. You will get this one. You will get this one. This means del u by del x equal to y sec square x plus sec x tan x. This is number 2. And del u by del y equal to tan x plus twice y. This is number 3. This is number 2 and this is number 3. From 2 u x y will be equal to integral y sec square x plus sec x tan x del x means we shall integrate with respect to x treating y as constant plus pi y. This is equal to with respect to x. What is this? Y is constant. Integration of sec square x is tan x. Y tan x plus what will be the integration of sec x tan x? It is sec x plus pi y. This is u x y equal to this. Suppose this is number 4. This is number 4. From 4 differentiate this with respect to y partially. You will get tan x with respect to y partially. This is 0 with respect to y. D. You will get this one. This is number 5. From 3 and 5 we get. Now, this is number 5. From 3 and 5 we get. You know, tan x plus d pi by dy equal to tan x plus twice y. This means d pi by dy, this is equal to twice y. This means pi y. Pi, of course, it is a function of y only. Equal to integrate this y square plus a constant c naught. Now, substitute this value of pi y in 4. Substitute this value of 5y in 4. We get so what happens here? Therefore 4 implies u of xy equal to y tan x plus sec x plus y square plus c naught. Now the solution of the differential equation is u equal to constant. Solution of one is u xy equal to constant. This is equal to c1. Say this means put the value of this y tan x plus sec x plus y square plus c naught equal to c1. This means y tan x plus sec x plus y square equal to c, where c equal to c1 minus c naught. This is the solution of that given differential equation. Y tan x plus sec x plus y square is equal to c. Y square is equal to c. We have solved these differential equations by method 1. Let us try to solve these differential equations by method 2. This is number 1. We shall solve this equation by method 2. Now, solution of 1 is, it is exact. We have already proved. we have solved this equation. Now, the question number 7 has been solved in 3 different methods. Let us come to solve this question number 8. Question number 8. Here m equal to, here m, this is equal to x by y square plus x. M equal to, m, this is equal to x square by y cube plus y, del m by del y, del m by del y with respect to y. Differentiate it. X is common, y to the power minus 2 means minus 2 y to the power minus 3. This is equal to minus twice x by y cube. Del m by del y is this. Del n by del x, del n by del x equal to twice x by y cube. Twice x by y cube. Del m by del y is this and del n by del x is this. Therefore, it is not exact. Suppose this is 1, it is not exact. It is not exact. It is not exact. This is not exact. Now, since this is not exact, we are asked to solve those equations which are exact. Let us come to solve this question number 9. Question number 9. Suppose this is 1. Comparing 1 with m st ds plus n st dt equal to 0, we get m st equal to twice s minus 1 by t and st equal to s minus s square divided by t square. This means del m by del t will be equal to minus twice s minus 1 divided by t square. Treat s as constant, twice s minus 1, 1 by t, minus 1 by t square. This is equal to 1 minus twice s divided by t square. Del n by del s equal to 1 minus twice s divided by t square. Therefore, del m by del t equal to del n by del s. Del n by del s. Therefore, 1 is exact. Therefore, 1 is exact. Therefore, 1 is exact. Since 1 is exact, therefore, there exists a function u of s and t such that m ds plus n dt equal to du. This means there exists a function u of s and t such that m ds plus n dt equal to du. This is a function of s and t, and m is a function of s and t, as it is a function of s and t. Therefore, what is m? Means twice s minus 1 divided by t ds plus s minus s square divided by t square dt. This is equal to del u by del s ds plus del u by del t dt. Del u by del t dt. This means del u, it is a function of s and t, by del s equal to twice s minus 1 divided by t, and del u by del t equal to s minus s square divided by t square. Divided by t square. Divided by t square. Suppose this is number 2 and this is number 3. This is number 2 and this is number 3. From 2, ust equal to integral twice s minus 1 divided by t del s plus phi a function of t only. Phi a function of t only. This means u st equal to, with respect to s, treating t as constant, what will be this? S square minus s divided by t. S square minus s divided by t plus phi t. Phi t. Suppose this is number 4. Suppose this is number 4. Now, Krishna, 4 implies, from 4 you will get del u by del t, del u by del t will be equal to s square minus, will be equal to s square minus s with respect to t minus 1 by t square. Minus 1 by t square. Minus 1 by t square. T square plus, with respect to t, d phi by dt. D phi by dt. Or del u st by del t. This is equal to s minus s square by t square plus d phi by dt. D phi by dt. This is number 5. Now, number 5. Now, from 3 and 5, del u by del t, del u by del t. From 3 and 5. From 3 and 5. Del u by del t equal to this s minus s square by t square plus d phi by dt. D phi by dt. This is equal to s minus s square by t square. This means d phi by dt equal to 0. This means phi t equal to constant. C naught is constant. C naught is constant. C naught is constant. Substitute this value of phi t in 4. Therefore 4 implies u st equal to s square minus s divided by t plus c naught plus c naught. The solution of the differential equation is du equal to u equal to constant. Du, since this differential equation m ds plus n dt equal to 0 is exact, therefore m ds plus n dt equal to du. The solution will be equal to the differential equation becomes du equal to 0, means u equal to constant is the solution. Solution of 1 is ust equal to constant equal to c1, say c1. What happens here? This means s square minus s divided by t plus c naught equal to c1. This means s square minus s by t equal to c1 minus c naught. This means s square minus s by t equal to c. This is the solution of the differential equation. S square minus s by t equal to c. The solution of the differential equation is this. S square minus s divided by t equal to constant. Or you may write here s square minus s equal to ct. S square minus s is equal to ct. We have solved this equation by method 1. Let us come to solve this equation by method 2. It is 1. 1 is exact. We have already proved this del m by del t equal to del m by del s. Del m by del s. Del m by del t equal to del m by del s. The differential del m by del t equal to del m by del s. It is exact. Since it is exact, therefore, solution of 1 is integral m ds treating t as constant, means twice s minus 1 divided by t ds treating t as constant. I'm writing here del s. This means treating t as constant plus taking only those terms in m which do not contain h, which do not contain s, means which are free from s. No term is there. No term is there. Therefore, 0 equal to constant. 0 is equal to constant. This means with respect to s, treating t as constant. What is the 1 by t? It is constant. Twice s, integration of twice s is s square. Integration of 1 is s divided by t equal to constant c. This means s square minus s is equal to ct. This is the solution, or you may write it, this is the solution of the differential equation. This is method 2. Now method 3. Method 3. Method 3. 1 is exact. Grouping method. Twice s minus 1 divided by t ds plus s minus s square by t square dt equal to 0. Method of grouping. This means you may write twice s by t ds. Twice s by t ds minus s square by t square dt. Just group this one. Twice s by t ds minus s square by t square dt. dt plus or minus, or you may write plus, minus 1 by t ds plus s by t square dt equal to 0. Just group this one. This means 1 by t twice as ds can be written as d of s square. It can be written as d of s square plus s square d of 1 by t, you may write like this. D of 1 by t is minus 1 by t square. It will be this. Plus minus 1 by t ds plus s d of minus 1 by t, you may write like this, equal to 0. You may write like this, equal to 0. Now, this means first function differentiation of the second function differentiation of the first function, d of 1 by t s square, you may write like this, plus it is also d of minus 1 by t into s equal to 0, or you may write d of s square by t minus s by t equal to 0, or d of s square minus s by t equal to 0. Integrating we get s square minus s by t equal to constant. This means s square s minus s is equal to ct. This is the solution of the differential equation. S square minus s equal to ct. This is the solution of the differential equation. Now, previously also, s square minus s by t equal to c. It is s square minus s by t equal to c. Therefore, we have solved this differential equation also in 3 different methods. Let us try to solve this one. Here, m equal to twice y to the power 3 by 2 plus 1 divided by x to the power half. M equal to thrice x to the power half y to the power half minus 1 del m by del y equal to, treat x as constant, 1 by x to the power half into 2 3 by 2 y to the power 3 by 2 minus 1. This is equal to 3 divided by x to the power half y to the power half. You will get this one. Del n by del x equal to 3 y to the power half. What is the differentiation of x to the power half? Half into x to the power half minus 1. This is equal to 3 by 2 y to the power half divided by x to the power half. You see here, 3 y to the power half by x to the power half. Here it is 3 by 2. Therefore, del m by del y is not equal to del m by del x. Therefore, suppose this is 1. 1 is not exact. Dear students, today I have solved from the exercise section 2.1 of the book, simply differential equations by simply L. Rose. From question number 5 to question number 10. In the last class, we solved 4 problems, question number 1 to question number 4. Therefore, in total, from the exercise section 2.1, we have solved 10 problems. Today, I want to stop here. Thanks for attending the class. Thank you very much. Thank you very much.